Okay, this begins the unit in the chapter 6 on rational expressions, and basically what we're going to do is extend the things that we do on regular fractions to fractions that involve variables. I've also have a link to the video from Mr. Whittington that explains this too, and it's actually in this unit is in 3 separate videos. So for right now, the thing that you're going to talk about is reducing the rational expressions. Basically, we're just going to be reducing fractions. So I want to go back and and just kind of refresh your memory on the way you would reduce fractions just like regular plain fractions. So here, if we were to reduce 6/8, we would look for a common factor that they all have. So we would say, well, we know that 2 will go into both of these, so I'm going to divide them both by 2, and the number that's left over then would be my fraction, which would be in lowest terms. So if I do 8/12, I'm looking for a number, the largest number that could go into both of those, and that would be a 4. So I'm going to divide both top and the numerator and the denominator by 4. And then I would have 2. 8 divided by 4 would be 2. 12 divided by 4 would be 3. So our fraction in lowest terms would be 2/3. 7/42. I would look and say, well, they'll both divide by 7, so I'm going to divide them both by 7. Now notice, when you divide a number that's the same, it doesn't cancel out to 0, it divides out to be a 1. So 7 divided by 7 would be 1. I have to have the 1 there in the numerator place, and then 42 divided by 7 would be 6. So my fraction in lowest terms would be 1/6. Now I'm going to go back and use this example right here. The other thing that we can think of is if we divide the 8 and the 12 into its prime factors, 8 would be 2 times 2 times 2. 12 would be 2 times 2 times 3. So then, as we're looking, any number over itself would reduce out to be a 1. So the other way that I look at this is, besides recognizing that 4 is my greatest common factor, if I look at my prime factors, the things that match can be reduced out. So 2 goes into 2, that'd be 1 time and 1 time. 2 goes into 2 here, that would be 1, and yes, that would be 1. And then 1 times 1 times 2, so I multiply what I have left would be 2. And 1 times 1 times 3 would be simply 3. So the idea of what we see right here by putting it in prime factorization is what we're going to apply to what we do when we use fractions that have variables in them. So here, if I look at 32 and 24, first of all, I would want to think, can I think of the number that would be the largest number that would divide into both of them? And yes, 32 and 24 will both divide by 8. So I'm going to divide 32 by 8. That would leave me with 4. 24, I'm going to divide by 8. That would leave me with a 3. So now the numerical factor reduced to lowest terms would be 4/3. For my variables, I have 5 x's on top and 1 on the bottom, so one of those x's is going to cancel out, which would leave me x to the 4th on the top. For the y's, I have more on the bottom, so whatever I cancel is going to be, the answer would be left on the bottom. So I have 9 y's on the bottom and 3 on the top, so the 3 on the top is going to cancel 3 out of the bottom, which was going to leave me with y to the 6th. So this would be my fraction reduced to lowest terms. Okay? Over here, they both have negative signs, so I'm just looking at signs. I know negative divided by negative is going to be a positive, so I can just ignore the signs in this problem. 60 divided by 4 would just reduce out to be 15. So 15, and at 15 would go on the top. 8 f's, 8 factors of f, and I'm going to get rid of one of those factors of f, so that would leave me with f to the 7th. And I have 7 factors of g, and I'm going to divide off 5 factors of g, so that would just be g to the 2nd. Well, that everything on the bottom disappeared, so technically there's a 1 right there, but since it's a 1, we don't have to keep the 1, and our final answer would be f to the 7th, g second with the 15 in front. So this would then be our final answer reduced to lowest terms. So when we work with expressions that is a single term on top where everything is being multiplied together, and here everything is multiplied together, we basically see all the different factors separated. But in polynomials, when we have things that they have to be in factored form, we would have to look at them as trying to find the sets of parentheses that match. So when you work with polynomials expressions, we've got to go back and use our factoring skills. So this problem is already factored for us. We have an x plus 2, a y minus 5, and an x minus 6. So then when we look at the bottom, we have y minus 5, x minus 6, x plus 8. And again, just like we did up here where we tried to find the things that match from the top to the bottom, we do the same thing here. They have to be in factored form in order to do that though. So I'm going to look at the top. I have a y minus 5, and here I have a y minus 5. So y minus 5 goes into itself once, here and here. X minus 6 will divide into itself one time on top and get 1 off the bottom. And then I look at what's left. Well, I have 1 times 1, which is still 1, times x plus 2, and that just leaves me with x plus 2. And then on the bottom, I have 1 times 1, which is still 1, and x plus 8. So the only factors I have left are x plus 2 over x plus 8. Now, here's the thing that I know that you think about. Well, they both have x's on the top, and they both have a factor of 2. They both have x's in the front and a factor of 2 in the second. But that's not times. That's x plus 2, not x times 2. So you can't simply just mark out the numbers because they look like. It has to be in a factored form. It has to be in a factored form here, so multiplied together. And here, they're not multiplied together. So this is all you can do. So once we've divided out the y minus 5 and the x minus 6, the only thing left is these two terms, and that is your final answer. You cannot reduce anything else because there's no more common factors. It's not written as multiplication here, it's written as addition. So the final answer here is x plus 2 over x plus 8. So I've got a couple of examples here that are already factored form for us if it's a polynomial. If they're already monomials or single terms by themselves, then you'll have to do like what we did right here. So if I'm looking at just the single terms, if I'm looking at just the 3x cubed and the 15x to the 7th, I'm going to work that problem like I did up here. So I'm going to look at 3x cubed and 15x to the 7th. Well, 3 can go into both of those, so 3 would go here once, and 3 would go in here 5 times. So I'm going to make my new fraction for my answer. I'm going to have a 1 on the top right here. I'm going to go ahead and put that 1. And I'm going to have a 5 on the bottom. Now I have x cubes and I have x to the 7ths. Now notice that 3 and that x cube are multiplied together. So now I can reduce out some x's. So 7 on the bottom, take away 3 on the top, is going to leave me with 4 of those x's on the bottom. Okay, now I'm going to go to my polynomial factors. Now I have them in parentheses, so I'm looking for the parentheses that match. So I have a factor of n plus 7, so n plus 7 and n plus 7, they'll each go one time into each other. So those will just basically divide off, and I'm left with n minus 2. Now on the top, 1 minus n minus 2 is not going to change the value, so you can leave it just as n minus 2, and on the bottom you'd have 5x to the 4th. Then this would be our final answer, reduced to lowest terms. Notice when we reduce fractions up here, we had 3/4. They didn't disappear to nothing. So yes, this is what our answer would look like. Okay, we'll get down to the next one here. The 3x and the 9x are multiplied already together, so we can simplify those just like regular fractions. So 3 can divide into both. 3 goes into 3 once. 3 goes into 9 3 times. So over here I've got a 1 and a 3. My x's, I have one on top and one on bottom, so that means those are going to cancel completely off, so I don't have to worry about those x's. Then I'm going to look at my polynomials and see what do I have. I have a y minus 5 on the top and I have a y minus 5 on the bottom, so those factors will cancel. They'll divide to 1. And y plus 9, those will divide off. So that's a 1 and a 1 and a 1 and a 1, which aren't going to affect anything. So what I have left, the only thing left is a y plus 4. So I'm going to write 3 and y plus 4, and that would be my final answer, because everything on the top just became a 1. So 1 times 1 times 1 is 1, and 3 times 1 times 1 is 3, and y plus 4 would be there. Now, you do not have to distribute. You can just multiply them. You can just leave them like that in factored form, and when you work on your homework, that's how they want you to leave the answers. You do not have to multiply them out. Okay, now here's the question on the bottom ones. These are not written as factors. So this is a polynomial. It's a binomial. It has to be factored before you can do anything with it. This bottom one is a binomial. It has to be factored. So I'm going to look. I have two terms. So there's a 4 that I can take out of both of those, and I'll have 4x plus 4. On the bottom here, I have a difference of squares. So I'm going to take, I have a common factor of 4, so I'm going to take out a 4. Then I'm going to have x squared minus 16. But x squared minus 16 is a difference of squares. So this one will break down again. I'll be able to break it into x plus 4 and x minus 4. So I'm going to erase that, just mark that one out. Now I'm going to look at everything that's factored and see what matches. If I don't have it factored, I can't do anything yet. So you've got to use your factoring skills. So I have a 4 over itself, so the 4's will divide off. That'll just be 1. And on the top, I have an x plus 4. And on the bottom, I have an x plus 4 and an x minus 4. So the x plus 4's will divide off. So I have 4 into 4, which is 1. I have an x plus 4 into itself, x plus 4, which is a 1. So the top just has a 1. And the bottom, the only thing left is x minus 4. So this would be our final answer in reduced to lowest terms. Okay, number 6. Number 6 is also a problem that has binomials. So what I have to do is factor them. So I'm going to look and first find, is there a greatest common factor? So yes, I can take 2 out of both of those and an x cubed. So I'll have 2x cubed. And then what's left over, that would be x to the first. And 12 divided by 2 would be minus 6. Then down here on the bottom, I can take a 6 out of both of them. And then I'll have x minus 6. So now I go back and look and see what things can I reduce. So the numbers out in the front have a 2 over a 6. Well, the 2, 6 goes back to the problems like we did up at the very top. So I can reduce a 2 out of both of those. So that would be a 1 and a 3. X minus 6 will divide itself. So those will each get to 1s. So on the top, I'm left with an x cubed. And on the bottom, everything but the 3 divided, so 3 times 1 would just be 3. So this one then would now be in lowest terms. Okay, the last two here on the bottom, the top of this one is a trinomial. So I have to go back and think, how am I going to factor my trinomials? So let's see, I can take out an x squared from each one of them. But I also noticed this on this problem. The highest power is at the back of this problem, and I really want my highest power in the front. But if I move the x to the 4th to the front, it's going to be a negative on the x to the 4th. So if I look at this turned around, it would be negative x to the 4th minus x to the 3rd plus 6x squared. Now, that doesn't work for me very well because I don't like having a negative on the front term, But so what I can do is I notice they all can take out an x squared. So when I do that, I'm going to take it out as a negative x squared, and that'll help turn all my numbers around for me. So I'm going to take out negative x squared, and then that changes your sign. So now this becomes positive x squared, this would become plus x, and then this would become minus 6. So my numerator here, I'm going to go ahead and take this and move it to the top, negative x squared, and x squared plus x minus 6. Okay, and down on the bottom I can take out an x cubed from both of them, and then I'll have x minus 2. Now, what can I do to this numerator up here? Because it's a trinomial and it doesn't match x minus 2, so I need to see what would be the factors for this trinomial. Well, it's plane because it has an x squared with a 1 on the front of it. So I'm looking for the factors of 6 that subtract to give me a 1. So let's see, I'm going to write it right up here. Those would be x and x. And I have 6, 3 and 2 would subtract to give me that, so that'd be plus 3 and minus 2. Okay, so I'm going to go ahead and just kind of scratch out that right there. And now I look and see what do I have matching. Well, the x squared and the x cubed can reduce, so there's more x's on the bottom. I'm running out of room here. So I get rid of those two, but notice that negative sign is going to stay there. And on the bottom, I have an x cubed, so that's going to be one of the x's left over there. Then over here, I have an x minus 2, so I'm going to get rid of that, and that leaves 1 there. Get rid of the x minus 2's. So I have a negative sign on the top, and then I have this x plus 3. So when you write it, just write it with the negative right there. And then on the bottom, I have that x left over. Now, there's one thing that's nice about negative signs, and when we work with fractions, you can either put, say for example, I have just a simple fraction. Say I have a fraction 2/3. If 2/3 is going to be negative, it can either be written with a negative in front of the whole fraction, or it could be negative with the 2 and the positive on the 3, or probably the least favorable is to put the positive and then put the negative on the bottom. I would say don't do it like that. But in a case like this, you could put the negative on the front. If you put it on the top, you must put this in parentheses because the negative has to be distributed to both numbers. So if you're doing this on your homework and you want to put the negative, you could put it negative and then put x plus 3 by itself, and then put an x on the bottom, and make sure the negative goes in the middle and the front of the whole fraction. Either of these would be acceptable answers, but if you put the negative on top, you have to put that in parentheses. Okay? Alright, this next one. It's two trinomials, so we're just going to look and start to factor them. So I need y squared, I need factors of 6 that subtract to give me a 5. So let's see, that would be 6 and 1. So I'm going to have y minus 6 and y plus 1. Now on the bottom, this one is going to have to be a rainbow problem. But if we think about it, we've got some clues up here that could help us. So we know that we want something down here to match and see what we're going to get. So I'm going to rainbow this one. So 2 times 3 is going to be y squared plus 2y minus 6. I think there's a typo on this problem. Would that be what we need? Yeah. This should be a 1 right here. So let's make that be a 1 so that our factors will work out better. I don't even think that'll work for us. Let's see. We'll work it out and see. So I'm going to have, yeah, this has to be a 1. So I'm going to have y plus 3 and y minus 2. Okay, now when I is that going to work? Yep. When I factor this back, I'm going to divide everything by 2, and I'll get y, let's see, what, 2y plus 3 and y minus 1. Oh, we've got a problem here. This one I have a typo on, and I forgot to go back and correct it. Let's make this, is that right? Yeah, let's make this plus. Then this is plus and this is minus. Okay, we can fix the numbers here. Alright, now we have 2y plus 3, and we have y minus 1. So now our y minus 1s will match, and we get y plus 6 over 2y plus 3. Okay, so if you're in class, you will see that I have this, I'll correct this before you work on it. But if you've missed class, then you're going to need to go through and fix this. So make it a plus 5y here, make it a plus 1 there, and when you do rainbow, it'll work out for you. So then this would be our final answer. Okay, so this section, if you go to Fort Bend Tutoring and you want to find a video that'll show you how to do this, they're going to call this simplifying. This would be the other way, simplifying rational expressions. Okay, so a YouTube video from Fort Bend Tutoring would be very helpful in this one. Now, the second set of problems on this is going to be multiplying rational expressions. Basically, multiplying rational expressions is just an extension of a little bit more factoring to do the same thing. So when we multiply fractions, most of the time we can multiply straight across and then reduce what's left. And so if I were going to multiply 12 over 25 times 5 over 8, I would look to see, are there any things above each other or diagonal that I could simplify out? So if I reduce that out, I can reduce 12 and 8 both have a factor of 4, so I can reduce that, and I'd have 3 and 2. 5 and 25 can reduce, that'd be 1 and 5, and then I just multiply what I have left over. So then I would end up with 3 over 10. Now, if I think about this, I can look and think back to when we broke the fractions down. If I start looking for all my common factors, 12, and that would be 2 times 2 times 3, because that would be 4 times 3. Let's look at the prime factors and see what's happening. And then here, 25 is 5 times 5. 8 is 2 times 2 times 2. So if we look and see at all the prime factors, now we can find pairs that match. Find something on the top that matches something on the bottom. So I'm going to divide a 2 out here and a 2 out there. Here's another 2 with another 2. So pair them up. And then I can divide a 5 with a 5. And then look and see what I have left over. So the only thing left, these would all be 1s when I simplify those. So the lefts would be 3 times 1, which would be 3, and 5 times 2 times 1, which would be 10. So I get the same answer, but you see the concept. Here we're basically dividing out common factors, and here we're looking at the pairs that can work out as factors here. So this again tells us that when we start to work with polynomials, they have to be in factored form before we can see what matches. Here's another example that's written as just regular terms together that are already multiplied out. You don't have, there's no factoring really that you have to do. So you can look and do with the numbers. We can look at the 18 and the 3, the 18 and the 15, the 2 and the 3. So we can look and simplify there and go a bunch of different directions with this. So if I go diagonally, I know 3 can go into 18. That would be 1 there and 6 there. 2 and 15 don't have anything in common, but I still could simplify straight up and down because 15 and 6 have something in common. So if I divide here, 6 and 15 both have 3, so I do this and get a 2. Here I'll get a 5. then I'm going to go back and look at my variables. So I'm going to go 2 times 2, that would be 4 for my numbers, and 5 times 1 would be 5. Now you just have to be careful when you're doing it this way, because sometimes you just get pencil marks and you can't figure out what you've done. Now go back and count x's. I have 2 on the top, and I have 1, 2 on the bottom. So that means all of those x's are going to cancel out. So I'm just going to get rid of the x's. So I'm not going to worry about them. Then I'm going to look at the y's. I have 1, 4 plus 1, so I have 5 on top, and I have 2 on bottom. So the 2 on the bottom are going to divide off 2 of the top, and that'll leave me with y to the third. W's, I have 5. 1 more would make 6, and I'm going to get rid of 2 of them, so 6 minus 2 would be w, and that would be on the top because that's where they all are, w to the fourth. So this would be simplified and reduced to lowest terms, because really I'm just extending all of it to one giant numerator and one giant denominator, and then I just look and see what matches, just kind of like what we did right here. So now on these that are in polynomial form, we have to factor. So first of all, look for your greatest common factor, see what you can do. So I'm going to have 2x plus 10. Let's see what I can do with that one. I can take out a 2, and then I'll have x plus 5. Alright, and then over the top of that, I'm going to go ahead and write that 2x cubed right next to it, because that's already a monomial. It's a simplified term that can't do anything else. Over on the bottom, I'm just going to go ahead and line that up underneath the other one, because they kind of match and they'll work together. And then on the bottom here, I can take out greatest common factor. I can take out a 4, and I'll get x plus 5. So now just go back and look and see what we've got. Well, I have a 2 and a 2 on the top, so 2 times 2 would be 4, but I have 4 times 4 on the bottom. So this 2 and this 2 can cancel one of those 4's, because 2 times 2 would be 4 to cancel a 4. And then I have x plus 5's. They'll reduce out to just be 1's. And I'm left over here with an x cubed and an x squared. So those are going to divide off, and this will leave an x on the top and none on the bottom. So what am I left with? There's an x on the top, that one by itself, and there's a 4 on the bottom. That's all we got. And there's your final answer. Okay, on the second one, number 2, we got to do some factoring. So I'm going to work down below this one just because I got a little more space. So the x minus 1 is in lowest terms. I can't do anything to x minus 1. If it's to the first power, there's nothing you can do to it. So this is just going to be x minus 1, and what I'm going to do is make one giant fraction. Now I'm going to go over to this second one. I'll go ahead and put this in parentheses. Here I have a trinomial, so I'm going to make 2 sets of parentheses. Factors of 6 that add up to 5, so that would be 2 and 3. And I'll put plus 3 and plus 2. Down here on the bottom, there's another trinomial, so I'm going to look at those factors. Factors of 6 that subtract to give you a 1, and that'll be a 2 and a 3. But the big term gets the negative, so the 3 gets the negative this time, and the 2 gets the positive. Okay, now I'm going to go over here to this last one. This is a binomial. It's a difference of squares. So this one would be x plus 1 and x minus 1. Now everything's in factored form. So we can go look and find parentheses that match. So there's an x minus 1 and matches there, so that goes one time. There's a plus 3 but minus 3 on the bottom, so those are not going to do anything. But x plus 2's will simplify. So I'm left on the top with x plus 3 and left on the bottom with x minus 3. Now, if you think that will reduce, plug a number in and see, because it's not going to work for you. If you let x be 5 and you think that that's going to divide off and that's going to divide off, and you put a 5 in there, you would see that those numbers don't work that way. This is your final answer. That's as lowest terms. That's all you can do. Okay? So again, here we have 3 trinomials that would have to be factored. So we're just going to go to factoring. First of all, if I look at this one on the top, plus 2, there are no factors of 2 that add up to 9, which means this one cannot factor. So I have x squared plus 9x plus 2, but then when I look at the bottom, hey, there's the same thing over here, x squared plus 9x plus 2. So that just means that whole thing is going to end up canceling itself. Then up on the top here, I can take out a 2, and I'll have x minus 2. Down here on the bottom, I can factor this trinomial. I think we factored one just like it. The only difference is this one will have 2 minuses, so it'll be x minus 3, x minus 2. So I know this one won't factor, but it'll completely cancel out the other one. And then I have a minus 2's, x minus 2's right there. So the leftovers will be a 2 on the top and x minus 3 on the bottom. Now, these homework problems right here should be like some of the homework problems that you have. I've gone through and tried to check them and make sure. So you'll have homework problems that match these. Okay? Over here, the only problem on this one is that we're going to have some numbers that are going to be rainbow problems. So I'm going to factor the easiest ones first. Here I've got just a regular trinomial, so I'm going to do that one. And I'll have y and y, factors of 20 that subtract to give you a 1. So that would be 5 and 4. So minus 5 and plus 4. And now here I have 2 rainbow problems. So you're going to have to go off on the side and rainbow those problems, and we'll get the answers for those. I'm going to be able to do this by looking at them. I know that 2y has to be 2y, and 2y squared has to be 2y and y. And 5 has to be 5 and 1. So this is kind of a trial and error problem, but if you rainbow it, you'll get the same answer. If I put the 5 here, I'll have 5 times 2, which will make 10. And 1 right here will give me 1. So 10 and take away 1 will give me 9. But I need the positive to give me the 10 and the negative to get me the 1, and then I'll get a positive 9. Now, as a hint, look at what you've got down here and think, if I'm supposed to be matching things, it's likely that this one is going to have a 2y minus 1, so that they end up matching. Okay, I'm going to just go ahead and guess at that, because 2y squared has to be 2y and y. It can't be anything else. And the only way to get a 1 is to multiply 1 times 1. So I'm going to put a 1 and a 1. And since this one's minus, I'm just going to go ahead and just guess that that's minus. And then I'm going to put a 1 here, a plus here, and if I check it, that would be 2y on my outer, and minus 1y on the inner is going to give me that number. So the fact that I got this one helps me kind of clue this one in, and I can kind of get a good idea that that's probably going to be the same. Now, when I get to this one down here, I have a difference of squares as it is, but the first thing I need to do is take out the greatest common factor, which is a 4. So I'm going to take out the 4, and then left over I'll have y squared minus 25. Well, I've got a y minus 5 and a y plus 5 up here, but if I factor this out, that's going to give me the y minus 5 and the y plus 5, because y squared minus 25 is a difference of squares. So I'm going to ignore that form and take these. So now I'll go back and see what we got. I got a y minus 5 and a y plus 5. That gets those. I have a 2y minus 1 and a 2y minus 1. Now, here on top, I simply have y plus 4. But on the bottom, I have a common factor of y of 4, but I have a y plus 1. And that's not going to be the same thing. So this would be final with you're going to have a common factor and a y plus 1. So these are all going to be some that you're going to find in your homework. Now, the last set of problems here are on dividing rational expressions. And again, if you go to some of the videos, the Fort Bend Tutoring has these in 3 separate videos. So you can watch enough of them if you want to go back and figure these out. When you start to divide, the difference in dividing and multiplying is one little step. How do you divide fractions? Well, you multiply by the reciprocal. Okay, so that means we're going to take the second fraction, okay, this fraction right here, and we're going to get its reciprocal. And then we're going to write them as a multiplication problem. So I'm going to write it now as 28 over 5. Then I'm going to go back and do just what I did up here on the top. It's going to be exactly the same. So I'm going to look and see, 7 and 28 have something in common, so I'm going to divide out the 7. That would leave with 4. Then I'll just multiply straight across, so I have 12 over 5 as my final answer. So when we have division in polynomials, that just means that this second fraction right here has to flip. Okay? So if we rewrite it, can we go ahead and factor it at the same time? Because that would mean this has to go to the top and this has to go to the bottom. So we can do that as we factor and do it in one step. I'm going to factor this top one. So that's a simple factor. And it's the same old ones over and over again with 5s and 6s. So I'm going to have y and y. Factors of 6 that add up to 5, so that's going to be minus 3 and minus 2. Now the bottom here comes to the top. So what can I divide out of 15 and 12? That's got to be a greatest common factor. Looks like I can take a 3. So I'm going to take a 3, and then 3 in here would be 5y minus 4. And down here on the bottom, I'm going to go ahead and stick this one on here. I can divide them both by 3. And that's going to be a 3y minus 4. Now, this one's going to be, we know that this has to be a 5y and a y. That's the only way you're going to get 5y squared. So if I know I've already got 5y minus 4 up here, 8 can be a 4 and a 2, so I would think that this factor has to match this factor, and so I'm just going to go ahead and go with that. This says my signs have to be the same, they both have to be negative. So this would be 4 times 2 would make 8. So I'm going to trust that, but I can still check it. 5 times 2 would be 10, and a not minus, and 4 times y would be 4, so 10 and 4 would add up to 14. If you do this one by rainbow, you'll get the same answer. Okay? But since we already factored some easy things and found 5y minus 4, we can kind of trust that that's going to be the one that goes here. And now go back and see what matches. So we can get rid of the 5y minus 4s. We can get rid of the y minus 2s. And these 3's that are by themselves can go. So my leftovers are y minus 3 over 3y minus 4. So yes, you can just go off and do the rainbow problem by yourself, or you can just think 5y squared has to be 5y and y. So we could place those and then we could see that that's going to match. Most of the time on these problems you'll be able to find that. Okay, so 2 more as examples, because these are like problems on your homework. Number 2, again, this second one is going to have to flip. Okay, so I'm just going to write that answer on the top and this answer on the bottom when I go factor them out. You'd have to be careful when you do this because you got to keep your brain concentrating. Okay, so on the top, I'm going to factor this one. I can take a greatest common factor. That'll be 3 and y plus 4. Okay, this 16y squared is going to come on top, so I'm just going to list it right back behind it. Y cubed, sorry. Okay, down on the bottom, I'm going to have an 8y cubed, so I'm going to line it up under the other y cubes right there. And then the 9y plus 36 has to move to the bottom because we're dividing. So I'm going to divide off that 9, and that'll give me y plus 4. So it looks like a lot of stuff is going to reduce out of this one. So 3 and 9, I can divide that once and this 3 times. And here I have the y plus 4s that match. And now 8 can divide into 16. That'd be 1 and that'd be 2. And y cubed can cancel itself, so those are gone. And so on the top, it looks like I just have a 1 times 2, which would be 2. And on the bottom, I have a 3 times 1, which would be a 3. So it simplifies out just to be 2/3. Are we good with that? Okay, now, this one is a whole number. This is like a whole number, so it would be over 1. So when we're gonna factor this one out, that just means this comes to the bottom and the 1 goes to the top. So now I'm going to make me one giant fraction bar. Let me see, I have x squared plus 2y minus 24. So let's see what we're going to do. That's a trinomial. It's going to have x's in the front, and to get the y's, they're going to be at the very back. And then I'm just going to do the numbers. The factors of 24 that subtract to give us a 2. It'd be 6 and 4. And the middle one gets the 6. So plus 6y and minus 2y. And on the bottom, this x squared plus 2 cannot factor because it's not a difference of squares, and there's not a common factor. So that's just x squared plus 2. And go ahead and put it in parentheses. Now, this x squared plus 6y was on the top, but because we're dividing, it's going to move to the bottom. And I can take an x out of each of those. So I'm going to have an x, and then I'll have x plus 6y. Okay, so that's all my factoring. And I've got a x plus 6y, x plus 6y, so I have that. And here I have an x, so left over I have an x and x squared plus 2. And on the top I have an x minus 2y. That's it. Nothing else cancels. We've already done all the canceling. Everything that reduces right here. When you get to this phase, nothing else should reduce. So you do it all inside here. There's your answer. Now, if you watch the video with Mr. Whittington, he introduces this in the middle of a problem that's in one of his examples. Sometimes when you're working with a problem, it's only, what we're going to do is only going to work if there's subtraction involved. Because x minus 5 is not the same as 5 minus x. But if you turn the 5 minus x around, this would become negative x plus 5. Well, they're awfully close, but the signs are different. And the one thing we can use to help change signs for us would be to take out and factor out the negative 1. So if I look at it and I see the negative 1, if I divide the 5 by negative 1, it's going to become negative 5. If I divide the x by negative 1, it will become positive x. So factoring out a negative 1 will change the signs for me. And now my x is positive, so it would be in the front. My 5 is negative, I can put it in the back. And now these two actually do match themselves. So if I look at this as x minus 5, my x minus 5s will now cancel, and I'm left with a positive 1 on top and a negative 1 on the bottom, and 1 divided by negative 1 would just be negative 1. So a negative 1 technique, we can make an adjustment so that the numbers would match. So on a problem like this, where the n squared is backwards, what I would do to turn the problem around is to pull a negative out. We did that on another example back at the beginning of this section. So if I want to turn it around so that n squared comes to the front and becomes positive, I'm going to put a negative and then make it n squared minus 49. That allows me to turn it around. It only works when you're working with a negative in there. And now on the bottom, I can keep that one as n squared minus 2n minus 35. Then the negative is going to be part of your answer, so go ahead and keep dragging it over. On the top, we can do a difference of squares. And we'll have n plus 7 and n minus 7. On the bottom, we have a trinomial, so I'm going to get me 2 sets of n's. And I need the factors of 35 that subtract to give me a 2. So that would be a minus 7 and a plus 5, because it needs to, the big number gets the middle sign. So now when I look at what's left over, I have a minus 7's that will cancel. Now my negative sign can go in the front, and then I can drop off all the parentheses, and I can have it like this. If you keep the negative sign on the top, it would have to be in parentheses on the top, okay, and n plus 5. So if you're going to type your answer in on your homework and you want to keep the negative sign, put the negative sign first and then put your little boxes for your fraction and put n plus 7 over n plus 5. Or put a negative and then put your n plus 7, but it has to be in parentheses, and then n minus 5, n plus 5. Okay, so on this one, if you look and see, the top has the y's in front and the x's in the back, and the bottom has the x's in front and the y's in back. Well, we wouldn't want to move this y squared to the front because it's negative. So I think it would be best to switch these two on the top around. And if we do that, we're going to have to do it by using a negative sign. And then we just switch them around, and we want 4x squared in the front minus the y squared in the back. And then on the bottom, we keep it like it is. It'll be 4x squared plus 8xy minus 5y squared. Okay, on the top is the easiest one to factor because it's a difference of squares. So I'm going to look at that and make that break apart, and I'll have 2x and 2x and a y and a y, one's plus, one's minus. Now that helps me know that something down here, if this is 2 and 2, then I'm going to go ahead and trust, without doing the rainbow method, that this is going to be 2x and this is going to be 2x. Now 5 has no option but to be 5 and 1. Okay, so I'm going to put my y's at the back. I'm going to put a 5 on one of them and a 1 on the other one. Now here's the thing to decide. I need my 8 to be positive on the bottom, so that means I need the 2 times the 5 to be a bigger number. So it's going to be the positive on the 5 back here, which would give me positive 10, and a negative here, which would make me have negative 2, and that's going to give me the positive 8xy in the middle. Now I can see it's going to match this one right here because it's a 1. So this one and this one will match, and then I have left over a negative, so I'm going to stick it out in the front, and then that would be 2x plus y, and then on the bottom I have 2x plus 5y. And so the negative sign sticking in the front just means you don't have to write parentheses on it. So this would be the quickest and easiest way to type your answer, because then you wouldn't have to type in parentheses. Alright, so negative 1 is only something you can use when there's minus signs involved and one is forwards and the other one is backwards. There's a couple of problems that you have to do that on some of your homework. So I hope that you find this video helpful, And if you weren't in class, then this will be the best thing to help you. And you also can go on and find the Fort Bend tutoring, and there's videos for all three of those there too. So I hope that this helps, and